Hello, everybody. Welcome to another PaaS DevOps virtual group. After a short hiatus over the summer, we've come back with a bang. Hamish is in a car in New Zealand and his connection is terrible, so we're not letting him speak today. Instead, you get me. I am going to tell you that our sponsors are Redgate and Influx Data, and we'll come back to that in a minute because, first of all, you want to know what we look like. So that's Christian on the left, looking amazing in a lift. That's Hamish carrying water because that's all he ever drinks, and I'm the one with the big beard and the big hat on the other side. So we have to go through some of these past community news things. First of all, hopefully everybody is aware that PaaS is running Summit 2019 in Seattle in a week and a little bit. And Microsoft is the biggest sponsor of PaaS, and they want you to come and take advantage of a 50% discount on the Microsoft certification. PaaS Board of Directors election applications have closed, so we won't be able to apply to be a board of directors, but you will be able to vote when that voting starts to come through, and there's some links there for how you can get in touch with PaaS about that. That one has gone. These are the slides for the end of the month, but they still have things about earlier in the month. PaaS Summit, if you still haven't managed to get a ticket yet, you can use our registration code to get $150 off the registration price. And also, if you see either myself or Hamish at the conference, please come up and say hello. We'd love to meet you and say hello. PaaS allows you to buy lots of stuff that you can then pick up at the summit, so that you can get an umbrella for that Seattle weather and a coat, and you can get that at paasstuff.com. Upcoming virtual group webinars or even virtual group webinars that have passed. Let's see if we can find any that are coming up. So tomorrow you've got a cloud webinar and a business analytics one. And then we've got some more on the 29th, 31st, and the DBA fundamentals crew are busy going for some in November the 5th. And into November. Here is the lovely picture of all of the different virtual groups that you can join and learn for free online, sat at home, or like me, sat in a hotel room. Upcoming SQL Saturdays. So we've definitely got Oregon coming up on November the 2nd. I shall be there. And that looks, oh, and Bangladesh. I was in Bangladesh last month for the PowerShell conference. It's a fantastic place. Very, very, very busy. If you are at PaaS Summit or if you are interested in a new job, you can use the paas.org careers website, which you can find the link of at the bottom. You can both recruit for new people and also look for new jobs. And please, as always, connect with PaaS on Facebook, on Twitter, on LinkedIn, on Instagram. Just find SQL PaaS or PaaS Community. And that's PaaS. So today I'm very pleased to have my good friend Andrew Pruski delivering a session. I saw this session in Munich and also a couple of times before. It's absolutely fantastic. And Andrew and I used to work together many, many years ago. So I've known him for a long, long time. Whilst you're watching this presentation, we want you to get involved, ask questions. You can ask questions in Slack at the SQL Server community Slack page, which you'll find there. You'll see that Christian is already in there ready to answer questions, and you can also ask questions via the questions pane on your GoToMeeting application, and at the end there'll be a survey, and from people who interact with us with that, we are going to give away the money that Influx Data have given to support our virtual group. So everybody, if you give it away and I get in touch and ask for an email address, that's why I'm doing it, so that I can use it for passing on a voucher of some dollars that we will get from Influx Data. So without further ado, Mr. Pruski, are you ready?
I am ready, Rob. Thank you very much.
Excellent. Let me just do Andrew Pruski, make presenter. There you go, buddy. It's all yours. I shall go on mute unless there's a reason to interrupt you.
Thank you very much. Can you all see my screen?
I can see the screen, yes.
Fantastic. Okay, welcome everyone to this session on SQL Server and Kubernetes. Just a quick bit about myself. My name is Andrew Pruski. I'm a SQL Server DBA and Microsoft Data Platform MVP, originally from Swansea, Wales, but I've been living over in Dublin, Ireland for about coming on to 6 years now. My Twitter handle and my email address are there. So if you want to get in contact after today, please feel free. I'm always willing to talk about this stuff. My blog's there as well, dbafromthecole.com. Posted multiple articles about running SQL Server in containers and on Kubernetes, some of which I'm basing this session on, and some of which go into a little bit further information. And then finally at the bottom there is my GitHub account, where all the slides and code for this session will be available, and I'll post a link to that at the end. Okay, on to the session. Now, the aim of this session is to give you some background knowledge and some code so that you can go away and start playing with Kubernetes yourself. So we're going to have a look at running a cluster locally on our laptops and spinning up SQL Server on that cluster. Then we'll talk about some of the Kubernetes components, and then we'll have a look at using a declarative method of deploying to Kubernetes. After that, we'll then have a look at persisting our data for SQL Server running in Kubernetes. For us, the SQL Server folks, fairly important. Then we'll have a look at something called Helm, a package manager for Kubernetes. And then finally, to round the session off, we'll have a look at some chaos engineering for SQL Server on Kubernetes. But first things first, what is Kubernetes? Now, the definition there is from the kubernetes.io site, and it says that Kubernetes is an open source platform for managing and deploying containerized applications. But what about Docker? Isn't Docker a platform for managing and deploying containerized applications? What's the difference? If you think about Docker, you install Docker on a single host and you run your containers there. That host is a single point failure. With Kubernetes, we have the option of having a fleet of hosts where we can run our containers, and we don't typically say to Kubernetes, I want to run on that node or that node or that node or that node. We just throw something into Kubernetes and it sorts what we want to run out in the background. It abstracts that infrastructure away from us. A little bit of history about it. The name Kubernetes itself is Greek. It means helmsman or pilot. And I always mention that because it explains the logo. You'll also see it abbreviated to K8S, and the simple reason for that is there are 8 letters between the K and the S. It was originally developed by Google. If anyone's read that TOOM, the Google Site Reliability Engineering book, I call it a TOOM because I've been trying to read it on and off now for a couple of months, and I think I'm only about 20% of the way through it. But in that book, it talks about Google's Borg system. Kubernetes came from Google's Borg system. In fact, its code name, whilst it was being developed, was 7 of 9, a friendlier Borg. And it's also why there are 7 spokes on that wheel. So it was originally developed by Google. It has now been donated to the Cloud Native Computing Foundation, and version 1.0 was released on July 21st, 2015. So over 4 years old at this point. So that's what it is. That's a little bit of history about it. But the main question I get asked when it comes to, especially running SQL Server on Kubernetes, is why? Why do I want to run SQL Server on Kubernetes? Think about all the platforms that we have for running SQL Server. We have physical machines on premises. We have virtual machines on premises. We have virtual machines up in the cloud. We have Amazon's RDS. We have Azure SQL DB. We even have managed instances. So why do I want to run SQL Server on Kubernetes? So a couple of jobs ago, I was working with a QA department, and they were having issues refreshing their testing environment. Now, their test environment was just VMs with a full production stack on each one, which meant each one had an instance of SQL Server. And they're constantly blowing these away, rebuilding and refreshing the environment, which meant they had to reinstall SQL Server each time. SQL was installed via Chocolatey. Chocolatey is like a package manager for Windows, and then a load of databases were restored via a series of PowerShell scripts. Now, this wasn't the most reliable process in the world. It was prone to failure, and when it did fail, the dev was left trawling through chocolatey error logs, SQL error logs, trying to figure out what went wrong, and then fixing it from there. In fact, I actually saw one chap blow away his whole VM and start from scratch because he didn't want to trawl through all those logs. Also, it wasn't the quickest process in the world. We're talking anywhere between 40 and 60 minutes just to get the database engine installed, and that was because of the spec the hosts the VMs were running on. So we decided to get away with all of that, ditch all the instances running on these VMs, and replace them with SQL Server running in containers on a remote host. Now, I have to admit, it was a bit of a bumpy road getting there, but once we finally got it working, it worked an absolute treat. We got it, the longest it took us to spin up a SQL instance, fully configured, with all the databases ready to go, was 2 minutes. Whichever way you look at that, that is a huge saving. It worked so well, in fact, I was sitting there and thinking, I don't really like this having to install SQL anymore. Why can I run containers everywhere? Can I run SQL in containers everywhere? Can I run SQL Server in a container in production? And I sat down and thought about it. And the longer I thought about it, the answer was glaringly obvious. And that answer was no. Think about what we built. We built a host running containers. That host was a single point of failure. And it did fail one day. We came in one day, the host was down. QA couldn't do any work until we got the host back up and running, and we got the containers with SQL Server up and running as well. We also found when we got towards about 40 or 50 containers, they become a little bit difficult to manage. Yes, the containers are up and running, but is SQL within them up and in a healthy state? If anything happens to those containers, are they going to automatically restart? If they do restart, do we need to persist our data? How are we going to manage persisting that data? These are the problems that containers have that orchestrators overcome. Orchestrators give us the tools to overcome these challenges. They allow us to perform health checks against applications running in those containers. They have inbuilt high availability with multiple nodes where we can run our containers. And they give us an easy way to manage our persisted data. So why learn Kubernetes? Kubernetes is the leading orchestrator out there in the market. It's doing so well, in fact, that its competitors, people like Docker, who have their competing orchestrator called Docker Swarm, are actually incorporating it into their platform. You can run a Kubernetes cluster in the Docker Enterprise platform, and you can run it locally using Docker Desktop, which we'll do in the demos in a little bit. So Kubernetes is a leading orchestrator out there, gives us tools to easily deploy and maintain containers. It's quick to spin up containers. We have the high availability built in. And if you're looking at SQL Server 2019 big data clusters, this is the technology that is built on. If you're looking at those big data clusters, I highly recommend you learn about Kubernetes as well. So let's get started working with Kubernetes. And the best way to get started is to run it locally. And we have a few options here. We have Minikube. If you check out the Database Avenger James Anderson's blog, he has got an absolutely great post about how to get SQL Server up and running on a Kubernetes cluster in Minikube. We have Docker for Desktop. Docker for Desktop, and I'll show you this in the next demo, is literally a tick box, and you can have a one node cluster running on your Windows 10 box. And then if you're running on Linux, I have a Ubuntu laptop, you can use Micro K8, and that does exactly the same as Docker for Desktop, gives you a one node Kubernetes cluster that you can deploy into. Other tools I'll be using, Visual Studio Code, absolutely great programming environment, but I'm not going to use it. I'm going to use Azure Data Studio, because with the Insiders release, I can get quite a lot of good plugins for Kubernetes, and I can get the Docker plugin, and I can get the Kubernetes plugin, and I can use things called SQL notebooks as well. And we'll go over all of these in the demos. And then finally there we have kube control, kubectl, 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 however you want to pronounce it. This is the main tool that we use to manage and deploy to our Kubernetes cluster. So let's go ahead and let's jump straight into the first demo, running SQL Server on a Kubernetes local cluster on my laptop. So I have Docker for Desktop installed. This is my Windows 10 box, and it literally is just a checkbox. you check that box, it will then go ahead and pull down a load of container images that contain everything that Kubernetes needs to get up and running on my laptop. And we can see down here, my Kubernetes cluster is running. Okay, so the first thing I need to do is get the SQL Server image that I want to use to deploy into my Kubernetes cluster. Now, Microsoft used to host all their container images on the Docker Hub, which was great because we could use a web browser, go to the Docker Hub and view all the images there. Or on the command line, we could use Docker search and search for the images. But unfortunately, they've now moved to their own container registry, the Microsoft Container Registry, the MCR, which means we can't use a web browser or Docker search, but we can use this little command here using invoke web request to this URL. And then we can list out all the container images that we can pull down and run SQL Server from. So the one I'm going to go for is, no, not the CTP, my mistake, the RC1 image, RC1-Ubuntu. And so you don't have to sit there and watch me pulling it down. I've already pre-pulled this image down. There we go. So I've got all my Kubernetes images here, but here is my SQL Server image. All right, so let's jump into some kube control commands. First thing I'm going to do is just make sure I'm running in the correct cluster. So config current context, that should say, oh, I am in the wrong cluster. So I can set myself to my Docker desktop cluster and then confirm nodes. So there we are. That is my one node Kubernetes cluster running on my desktop. So let's go ahead and let's deploy. I'm going to say kube control run a deployment called SQL Server from an image, the image that I just had a look at, the 2019 RC1 Ubuntu image. And this should look familiar to anyone who's run SQL Server in a container. I'm going to accept the end user license agreement and set an SA password. There we go. Got a warning there because I'm using some out-of-date syntax, but it works, so I don't really mind. So I can check my deployment. SQL Server, ready 1 of 1, up to date and available, all looking good. I do something and view something called a pod, and we will cover these concepts later. I just want to show you how easy it is to get up and running with this. There we are. I have a pod up and running, something called SQL Server. And I can jump into that pod. Similar to Docker exec, jumping into a container. Navigate to where SQL command lives. Connect to SQL, and then I can run, say, like ATAP version. And there we are. SQL Server 2019 RC1 running on my Kubernetes cluster locally on my laptop. But that's a bit naff, really, having to exec into the pod, navigate to where SQL command lives, and then connect in. What I really want to be doing is connecting from Azure Data Studio from my local desktop into SQL Server. So what I need to do now is expose that deployment. So I'm saying expose my deployment SQL Server, type of load balancer, which we'll cover, and then port 1433 to port 1433. So 1433 on my laptop to port 1433 in my deployment, which is the default port of SQL Server. So hopefully I'll be able to connect. There we go. I've exposed it, and by doing get services, I can see what it's exposing. If you deploy using expose a service with the type of load balance from Docker for desktop for Windows, you will get the external IP of localhost. So I need to grab that, drop it here. I can click manage. Oh, get rid of that. Haha. Thank you. Come here. I know why that's happening. Get rid of that. Thanks. There we go. Shortcuts. Come back here. There we go. Query, and I can just do let's do a select ATAP version. There we go. There we are. So we've connected from our local desktop into SQL Server running in a pod on our one node Kubernetes cluster on our laptops. Let's do a little tidy up. Okay, great. Jump back into the slides. So what we did there was spin SQL Server up on a one node Kubernetes cluster, but that's not how Kubernetes works out in the wild. You will have a cluster with multiple nodes, and there are two different types of nodes. The first one being the master node. And this does exactly what you think it does. It controls our cluster. So it has all the components for controlling the cluster on it, starting with the Kube API server. This exposes the Kubernetes API and processes RESTful operations. Everything in Kubernetes is represented by a RESTful resource. We call them the Kubernetes objects. They live in the cluster store, and each one of them has a unique HTTP path. When we run kube control commands, we are making requests to the API server that's pinging us to those unique HTTP paths so we can pull information about the objects that reside at them. So when I say kube control get pods, I'm making a request to the API server, which is hitting that unique path and pulling information about the pods that are running on my cluster. I mentioned the cluster store there. Most commonly used technology is etcd, a distributed key value store that holds information about the objects running on our cluster. We then have the kube scheduler. This is what decides which nodes our pods run on based on various algorithms, things like node resources consumed on the nodes. We then have the kube controller manager. This manages controllers in Kubernetes, and controllers are responsible for things like responding when a node goes down, ensuring the correct number of pods running on our system, and mapping services to pods. And finally, we have our cloud controller manager. This is what hooks Kubernetes into the underlying cloud provider. So Kubernetes can access that cloud provider's resources. For instance, spinning up a service with a type of load balancer. Cloud controller manager will hit the underlying cloud provider and say, hey, I need a load balancer for this service, and a load balancer will be spun up. So that's our master, controlling our cluster. But we don't run SQL Server on our master. We run them on the second type of node, and that would be the worker nodes, which are responsible for running and maintaining our pods. And this contains things like the kubelet. The kubelet takes a pod spec from the API server, and it shows all pods in that pod spec are in a healthy state. We have the kube proxy. Now this enables service abstraction by maintaining networking rules and connection forwarding, and we'll cover services in a little bit. And then finally, we have our container runtime. Say Docker, for instance. This is what's actually spinning up our containers on our worker nodes. So we have our master controlling our cluster. We have our worker nodes where we deploy our pods. Pods. I keep saying that word. What is a pod? Now, the way I like to think of it is the icon for Docker is a whale, and a group of whales is a pod. A pod is a group of one or more containers, and they are the smallest deployable units of computing within Kubernetes. So we don't deploy containers themselves in Kubernetes, we deploy pods. And a good example of this would be, say, a pod containing an application container and a logging container. Application container serving app requests and sending metrics and logging across the logging container, which is then writing it down to shared storage. And of course, the containers within the pod share storage, and they share networks. They have one IP address and they're exposed on different ports. Now, pods in Kubernetes are mortal. They die and are reborn. And when they are reborn, they come up within the cluster with a different IP address. Now, that poses a problem for us if we're connecting to those pods via their IP address. If pod goes down, comes back up with a different IP address, we've lost our connection. This is where services come into play. Services providing stable networking endpoint and abstract one or more pods away from us. So we don't connect to the pods themselves, we connect to the service, and the service routes our connection through to our pods. And there are different types of service. We have cluster IP. The service gets gets an IP address that's only accessible from within the cluster. Node port. The service is exposed on a different port on each of the nodes of the cluster. Load balancer. This service will get an external IP address that we can use to connect externally from our cluster. An external name. We can map our service to a DNS address. So we have our master controlling our cluster. We have our worker nodes where we deploy our pods. We have our pods where we run our containers, and we have our services that we use to connect to the applications running in containers in the pods. In the first demo, I used an imperative method to spin up SQL Server on Kubernetes. I told Kubernetes what I wanted it to do and how I wanted it to do it. I said, Kubernetes, run this from this. But that's not typically how we would deploy to Kubernetes. We'd use a declarative method. And we'd use YAML files. We'd define what we want to deploy to Kubernetes in a YAML file, push that into Kubernetes, and just say, work out what's in this YAML file and deploy that. So here's an example YAML file, starting off with a kind at the top there, kind deployment, type deployment, and then some metadata. We're going to give this deployment a name. We're going to call it SQL Server. Then we're specifying a number of replicas. What this is saying is that any one time I want one pod running in this deployment. Now, Kubernetes has this concept of desired state versus running state. We are defining our desired state in this YAML file. And when we push it into Kubernetes, it then becomes our running state. And Kubernetes is constantly checking between the two to see if there are any differences. If there are, Kubernetes will fix that for us. So I'm saying here, I want one pod running for this deployment. If anything happens to that pod, Kubernetes will automatically fix that for me. So we define how many pods we want. We better define what we want in those pods. So let's spec out our containers within the pods. And here we go. We're going to say a name, SQL Server 1, from our 2019 RC1 Ubuntu image, open up a port, 1433, and then specifying our environment variables. So we've got our SA password and accepting the end user license agreement. Now, I admit this is bad. I have the SA password in clear text in a configuration file. And there is a feature of Kubernetes that we can use to sort that, and I'll show you that in the next demo. But there we are. We have the number of pods we want, and we have what we're running in our pods in our deployment. But remember, we're not going to connect to our pods. We're going to connect via a service. So we need to spec that out as well. So kind, type, service, giving it a name. I'm terrible at naming things, so let's just call it SQL Server-service. Mapping our ports. So I'm saying here, target port and port. So what this is saying is that if anything hits my service on port 1433, automatically route that to a pod and hit that pod on port 1433 as well. And that's how I'll be able to use this service and connect to SQL Server running in that pod. And then finally, I have a selector, which is how I'm going to map my service to my pod. And at the bottom there, I have a type of load balancer, same as the first demo as well. So let's go ahead and let's use a declarative method to deploy SQL Server on our local Kubernetes cluster. Double check I'm in the right place. There we go. Yep. Make sure I'm where my YAML files are. And here is the YAML file. It is pretty much exactly the same as the one in the slides. In fact, it is the one in the slides. So I've got my image, my environment variables, and I've got my service here as well. So let's go ahead and deploy. Now, I'm not saying run, I'm just saying apply this file. Using a declarative method, I'm pushing this file into Kubernetes and letting Kubernetes work out what I want it to do. Here we go, I've got my deployment created and my service created as well. So check my deployment, up-to-date available ones, and I can view my pods. SQL Server 1 of 1, all good, okay. I get some more info on my pod. I can see its IP address within the cluster, 10.1.0.38. And I can pull out even more information by doing a describe as well. Okay. If we look at the bottom here, we can see the events that have happened. So we can see the scheduler working out where it's going to assign this pod. Now, it hasn't got much of a choice. I'm running a one node cluster, but that's a scheduler kicking in, deciding where the pod is going to be deployed. Then I've got the kubelet telling me that the image already exists on the machine. Now, this is something to be wary of if you are running multiple nodes and you've got the pods running on one node, but you don't have the images on any other node, and a node dies and your pods move across to the other nodes, that image will have to be pulled before your pods can be deployed. And so their spin up time will take significantly longer. So always a good idea to pre-pull your images down on your nodes. And then we can see it saying, created the container, SQL Server 1, started the container, SQL Server 1. Let's have a look at the service. Should be exactly the same as before. We use the same service type of load balancer, so it should be localhost. There we go. And then let's have a look at the IP address of that pod again. So I'm going to connect back in Azure Data Studio. Let's see if I can. There we go. Go to manage. All good there. And now I'm going to open up a notebook. And I'm just going to confirm the version. And let's say create a database. Let's have a look at where those files are. There we go. They are on var opt ms SQL data. This is the default location for SQL Server database files for SQL on Linux. Let's say, why not? Let's put some create test table, insert 200 rows. There we go. Excellent. I'm going to clear that out. Do a refresh there. There's our database. And now what I'm going to do is blow that pod away. So I'm just going to grab the pod name. And then say goodbye. Now what's happened here is the running state no longer matches the desired state, because I always want one pod running. I've deleted that pod, and Kubernetes has worked out there's a difference between the running state and the desired state, and has automatically spun me up a new pod. And we can see the age there of 15 seconds. We can also see that its IP address is different as well. It's a new pod, it's got a new IP address. So let's have a look at what's happened to our database. Boom, it's gone. The reason that has happened is because our new pod, once I deleted the old one, the new pod was spun up from the 2019 Ubuntu image, but that doesn't have any knowledge of that database that I created. That was a data change after the initial pod spin up. So I've deleted that pod, new pods come up, it all looks fine, but I've lost that data. And when I say lost, I mean lost. I cannot get that data back. And for me, as a SQL Server DBA, that is terrifying. So we need a way to persist our data for SQL Server in Kubernetes. So I'm just going to do a little cleanup before we jump back into the slides. Go. So let's talk about persisting our data, because Kubernetes is the same problem that Docker containers do. Any data changes that are not persisted on some sort of persistent volume will be lost if that pod dies and comes back up. It's the same as blowing a container away and spinning up a new one. You've lost those data changes. So the first thing we need to consider when we're persisting our data for SQL Server on Kubernetes is persistent volumes. Now, persistent volumes are just a piece of storage in the cluster. But the key point here is that their life cycle is independent of the pods. So pods can be spun up, blown away, spun up, blown away. We still have our data. And they can either be provisioned dynamically or statically. Statically just means we go and create storage. It could be Azure disks up in Azure. But I like to create them dynamically, and that's what I'm going to show you now. But before we do that, there's another concept to consider with persisting our data for SQL Server on Kubernetes, and that is a persistent volume claim. Now, a persistent volume claim is just a request for storage by a user, and we request size, gigs, and access types. And then the pods use the persistent volume claim and reference that. They don't reference the persistent volume themselves. Remember, we're abstracting that infrastructure away from us. So let's go ahead and let's have a look at doing that. And let's go back and jump into some YAML files. Now I said I wanted to create persistent volumes dynamically. So I don't want to be creating persistent volumes. I want to be them spinning them on the fly. And the first thing I need to do that is define something called a storage class. And that's exactly what you think it is. It is a class of storage. And this one here is for Azure. It's using the provision of Azure Disk, storage account type, standard local redundant storage kind of managed. And once we have that storage class, we can then reference it in our persistent volume claim definition. So we have our type here, persistent volume claim, some metadata, MS SQL data, access mode of read write once. What this means is that at any one time, only one node can access this persistent volume. So we don't want multiple nodes hitting it, we just want the one. We're referencing our storage class and then our size as well. I'm going to go with 1 gig purely because this is a demo. I also will be sitting here waiting while it spins up like a 100 gig disk for us. So once we create that persistent volume claim, it will go ahead and create our persistent volume for us dynamically in the background. So we don't have to have a separate bit of YAML to spin up a persistent volume. It'll all happen in the background for us because we've referenced we've used our storage class, and then we've used a persistent volume claim. Okay, before we jump into the demos, I did mention in the last section that I was putting my SA password in clear text in my YAML file, which is a bad thing. So what we can do to stop that is use something called a Kubernetes secret. So we just say kube control, create secret generic, and we're going to call it MS SQL from literal SA password testing 1122. And then we can reference that in our YAML file. So we don't have to have our SA password in clear text. We can then reference our secret, and that hides that password away in our config files. Much better than having it in clear text there. But be warned, there is a massive gotcha with Kubernetes secrets, and I will show you that in the next demo. That's how we reference our secret in our YAML file. And this is how we reference our volumes and our persistent volume claim. So we have our mount path. Oh, hello. And here I'm going to mount it as var opt MS SQL. Remember, when we create our database with no extra, we just said create database. We weren't specifying anything. It just created on var opt MS SQL data. That is a default location. So we're going to slide our persistent volume underneath that location. And then we're giving it a name and referencing our persistent volume claim. The pods reference the claim. They don't reference the persistent volume itself. Okay, so let's go ahead and let's have a look at persisting our data for SQL Server running on Kubernetes. I grab my
Can I interrupt just for a second, Andrew?
Yes, of course.
So we've had a couple of questions come through. Number one question is, how much memory and RAM are required for the Kubernetes that you're running right now? I presume it means on your local machine with the local kube.
So I am running this here with 2 CPUs and 2 gig of RAM.
Wow, is that all? That's amazing. So pretty much anybody could use that on a laptop then.
Yeah, pretty much. It's all controlled
Okay.
here.
The other question is probably going to take you a little bit longer to answer, and it is SQL on Kubernetes considered different from running SQL in a Docker?
No, we are using exactly the same image. So if you spin SQL Server up in a Docker container, you will get the same instance as you would spinning it up on Kubernetes. Remember, we are using, where are we? Let's have a look at the YAML file here. SQL Server here. We are using this image. So if I spun up a Docker container, I'd say Docker run from that image, whereas with Kubernetes, I'm saying run SQL Server from that image. So the SQL instances themselves are exactly the same. It's a little bit different about how we're going to connect in, because we're using a service for Kubernetes, whereas with Docker, we would use port mappings from the host into the container directly. But in essence, the SQL instance is exactly the same.
So I've got one last comment that's come through that says, that is amazing. I'm getting my dev people onto this right now.
Absolutely fantastic.
Show us some demos, fella.
Okay, let's persist some data, shall we? Okay, so I usually use micro-K8s for my demos. I haven't used Docker Desktop for this demo for a while. So here we go. Here's my storage class. A little bit different from one in the slides because I'm running locally. So I've defined its type of storage class, given it a name, again with the terrible naming conventions, test storage class, and the provisioner here, docker.io.hostpath. Now what that means is I'm going to be deploying my persistent volumes on a location on my laptop, and we'll be able to see that in a minute. So let's create that storage class. There we go, looks good. And there we are, the test storage class there. Now I didn't really need to create that because I could have used the default. There's already one there created for me, but I like to show you step by step and not rely on things that are already there. But I could have referenced that, but we're going to continue using the test storage class there. And now I'm going to create my persistent volume claim. Pretty much the same as in the slides. Access mode read write once, storage class name test SC, storage 1 gig. So let's go ahead and let's create that. Excellent stuff. Okay. And let's have a look at that persistent volume claim. Okay, so we've got status of pending. There we go, status of bound. And if you look to the next column here, we have our name, status of bound, and our volume. What this is saying is that it has spun up dynamically our persistent volume and bound our persistent volume claim to it. So I've got my capacity, I've got my access mode read write once, and my storage class here. And so let's have a look at the persistent volume. There we go, we've got its name there. Capacity read write mode, same as persistent volume claim. Status of bound, we've got our claim and our storage class. One thing to note here is reclaim policy. There's a delete. What this is saying is that if I delete my persistent volume claim, it will also delete my persistent volume. Probably not the best idea in the world. You can set this to something called retain, which means if you delete your claim, the persistent volume won't be deleted in the background. But this is a demo. It's going to make me easier for me to tidy up. I'm going to leave it as delete. Now, if I have a look at that persistent volume, if I do a describe, and if I clear this out, wait for it, there we go. I can see where my persistent volume actually lives on my host. So I can drop in here, and there it is. Nothing in there yet, haven't dropped anything on there. Okay. Let's go ahead and let's create our secret as well, because that's going to be in our YAML file, so we need that. I can view my secret. I can try to be a bit cute and see if I can get at that volume, at that data, but no, I can't see it. However, if I go over here into the Kubernetes plugin for Azure Data Studio and VS Code, view my cluster, come down to config, secrets, in your own time, there we go. SA password, click that, boomf, there is my data. Secrets in Kubernetes are encoded. They are not encrypted. So even though they're great at not having clear text values in our YAML files, they are not as secure as you think they are. Just be aware of that. Okay, let's go ahead and let's deploy SQL Server with our persistent volume. Same as in the slide, so let's go bang. Let's have a look at our deployment. All looking good. View our pods. We got the one there, states of running. Now that's up and running, which means, oh, okay. There we go. Ha. There are our system databases because we mounted that, remember, under the var opt MS SQL. Actually, I've mounted it with var opt MS SQL data. So it's just got the system databases there, but there they are, spinning up, deployed into the location on my host that I specified. So that was dynamically specified by the persistent volume being spun up in the background. So I get my service as well, and because we deployed the type of load balancer, we will have a type, the external IP of localhost. So I can come back here. Let's come here and let's do this. Let's do manage. Okay. Oh yeah, just wanted to show you this as well. There we are, there's the IP address, 10.1.0.40. Get rid of that. The localhost, and let's do the same thing as the previous demo. Let's open up a notebook. Let's confirm our SQL version. There we are, 2019 RC1 Ubuntu. Create our database. Come on, there we go. There's our files, var opt MS SQL data, and insert 200 rows. There we go. And then if I look here, there's our database files. Okay, so coming out of here, let's do a refresh, see our database. Excellent stuff. Okay, exactly the same as in the previous slide. Let's go ahead and delete that pod. So I'm going to grab the pod name. And let's delete it. So again, the running state no longer matches the desired state because I've deleted that pod, and Kubernetes will spin me up a new one in the background. Different IP address, but this time we have our persistent volume claim and our volume. And we can see that the database files are still there as well. So if I come back here, do a refresh, our database is still there. And I can jump into another notebook just to prove I'm not cheating. Do a select. Come on. Okay.
Try an F1 and a reload.
Yep. What I will do is not do that. And do that. Boom. There we go. There's our test database down there at the bottom. Okay. So we have our database there. So there we are. We've persisted our data. So we've spun a pod up, slid a persistent volume underneath it, created a database on it, blown that pod away, and Kubernetes has automatically spun us up a new pod, and our data has been retained. So we haven't lost anything. Okay, so let's go ahead and let's do a little bit of a tidy up, and we'll jump into the last bit of the presentation.
We have another question just before
Yes.
that, if possible. Can you set up multiple volumes, such as for transaction logs, for data, for temp DB, maybe to split out partitions, etc.?
Absolutely, you can. And in the next demo, I will show you. Yep, I'm only using one because this is a demo, but absolutely, you have one for data, logs, backups if you wanted. And we'll have a look at that now. Okay. So we've had a look at a lot of YAML files. I usually ask in these presentations, hands up, who here likes YAML? And I think I've had about one person put their hand up. It can be a bit fiddly. One thing I would recommend is one of the great things about the Kubernetes extension for VS Code and Azure Data Studio is that it will tell you of any formatting errors in your YAML file for Kubernetes. So say if you've got 3 spaces instead of 4, it'll throw a warning at you. It makes it really nice to work with it. But instead of working with YAML files, wouldn't it be nice if we had a package manager for Kubernetes that we could use instead? And yep, you guessed it, we do. It's called, continuing the nautical theme, it's called Helm. It is a package manager for Kubernetes, and it has a hub similar to the Docker hub. It's the Helm hub, where we have these packages that are called charts that we can use to deploy applications to Kubernetes. And there is a SQL Server available up in the Helm hub as well. So coming along to the end of the session, I'm not going to spend too much time talking about it. I'm just going to show you how it works. Come out of there. Okay, I am now going to switch to my other cluster, and this is an AKS cluster running up in Azure. Helm comes in 2 parts. We have the Helm client, and we have Tiller that runs up on the clusters. And we can install Tiller by seeing Helm in it, but already done that, so I can just confirm the versions of my client and my server, and they both match, which is great. So now I can do, similar to like a Docker search, I can search for a SQL Server image on the Helm hub. And there we go, we have the app version there, which I believe is SQL Server 2017 CU5. So I could do a test run of that. I could do a dry run and a debug, and it would tell me exactly what it's going to do. So it's got the chart. Here we go. And we can see here, we have persistent volume claims for our transaction log, our data, our backup, and our master area. So we can have multiple volumes attached to a pod. If we scroll up, we can see the image that's using, and it is SQL Server 2017 CU5. So don't really want to use that. I want to use 2019. So I built my own repo up on GitHub, called it DBA from the cold. There it is. And I can do a search for my 2019 chart there as well. And please ignore the app versions. It's something I mean to fix, but I was going with the CTP. So I was doing 0.3.1, 0.3.2, and then they went to RC1. So I went, I don't know, how about 4? But I will come back and fix that at some point. So I can do a dry run here with a debug, and it'll show you what I'm doing. And this is just some very basic YAML files in there. And yep, again, Andrew, need to sort that out. But we're going to use the 2019 RC1 Ubuntu image. So let's go ahead and let's deploy that to my AKS cluster running up in the cloud using Helm. Boom, there we go. Let's have a look at that deployment. Looks good. And we can check, same as before, we can check the deployments. We get our pods, and we can list our services. There we go. And you've noticed there that the service here has now got an external IP state of pending. What's happening here is I've deployed a service with a type of load balancer up to an AKS cluster. A load balancer type service needs a load balancer to be deployed for it. So the Cloud Controller Manager in Kubernetes has hit Azure and said, hey, I need a load balancer for this service. Spin me up one, please. And give me an external IP that the user, myself, can use to connect from outside of the cluster. Let's see if that's spun it up yet. There we go, we've got our external IP. If I describe the service, we can see the events. Here we go, we've got the service controller saying, ensuring the load balancer, ensure the load balancer. And that has a dependency on the Cloud Controller Manager. So I can take that external IP, and I can do, let's do new connection. Sometimes the external IP comes up. Oh, there we go. Nope, it's there, and that's connected to SQL Server running on a Azure Kubernetes service cluster up in Azure, deployed via a Helm chart. So we have that option as well. We have that nice package manager that we can use to deploy our applications into Kubernetes. I'll close that and disconnect this. And let's disconnect there and do a bit of a cleanup. Okay, so it's coming towards the top of the hour, so we're going to dive into the last couple of slides. Because what I want to talk to you now, and how I want to round out the session, is I want to talk about something called chaos engineering. I don't know if anyone's heard of chaos engineering, but I like to call it the art of turning stuff off and seeing what happens. Now, we've been testing the high availability capabilities of Kubernetes by deleting those pods and seeing them recover. Now, that's great. I mean, I live in the command line, so I really like that. But wouldn't it be nice if we wanted to demo this platform to a wider audience? We could have a GUI where we could show how SQL Server recovers running on Kubernetes. And wouldn't it be great if that GUI was Space Invaders? I found this GitHub project a few months ago now, and it's absolutely fantastic. It is called Kubernetes Invaders. I will send a link to the end. If perhaps it runs on any cloud provider, it'll run on EKS, Google Cloud, and it'll run on AKS, which I'm going to show you now. And we are the spaceship, and the invaders are our pods. So let's go ahead and let's have a look at this. What I'm going to do is make sure I'm in the right cluster. I think I am. And I'm just going to run what we did using the imperative method, just going to run a deployment called SQL Server from our image, but with 10 replicas this time. So let's wait for those to come up. Let's wait for those. There we go. We've got 10 pods running. And I can now jump over, and there's my 10 pods. There we go. No, go away. And if I do a kube control get pods, it's in a custom namespace. I can do a watch. There we go. And now, when I play the game, I can blow away pods, and we can see the pod terminating and then recreating. And this will sync back up. There we go. There's my 10 pods again. And I can test this out, and I can demonstrate how SQL Server will recover running on Kubernetes. And what's really cool is I can just hit automatic here and just let it go off and play. So if you ever want to demonstrate the high availability capabilities of Kubernetes, this is an absolutely awesome way that you can do so. And I absolutely love this. It's one of the best things I've come across. It's fantastic. I'll give you the link to the end at the end of the demonstration, at the end of the session, about where you can get this on GitHub. Okay, and that is the hour. So jumping back into the slides very quickly. Here we go. Here's some resources for you. The top link here is a link to my GitHub repo where the slides and the code are available. The next link down is a link to my blog. It's a summary of all the blog posts that I've written about running SQL Server on Docker and on Kubernetes. And then finally there's a link to the Kubernetes Invaders repo on GitHub as well. Rob, do we have any more questions?
Literally the only question was the question about are you going to publish all of your scripts and demos?
There we go.
So that is definitely up there.
Well, I will jump on to the community Slack for a little bit now as well. So if anyone wants to, I'm DBA from the Code on SQL community, so feel free to ping me there as well.
Okay, so we'll just give people just a couple of minutes. Anybody going to be jumping into the questions and asking the question, please do so now. Then you can get Andrew to answer your question live and on the internet. Otherwise, we can retire to the SQL Server community Slack. Looks like everybody else Too shy, Andrew.
No worries. Well, I'm at DBA from the Cold on
Oh.
Twitter, and my email is dbafromthecold@gmail.com. So please feel free. If you've got any questions, please just ping me.
Okay, we've got a question, and if I
Yes.
can open up the thing. Active Directory authentication, does it work?
Not as such, no. It is SQL Server authentication at the moment.
That's the only way. Do you think that's going to be like that for a long time?
Well, Bob Ward at Munich, I went to his session, and he said they are working on it. So watch that space.
Excellent. Okay. That's looking good.
Okay.
So where are you going to be talking next, my friend?
What's next for me? We've got the two Portuguese SQL Saturdays coming to Lisbon and Portugal at the end of November is the next ones for me.
Excellent. Excellent. Well, have a wonderful time. Thank you very, very much. Doesn't look like there's any more questions on the webinar.
Fantastic. Thank you for inviting me. Really enjoyed.
No, it's been brilliant. And I will speak to you very soon.
Take it easy, my friend. And thanks everyone for attending this session.